So, last class I discussed the heat capacity, molar heat capacity, and then I discussed why molar heat capacity is a intensive property and whereas heat capacity is a extensive property. And moreover, if you look at, I discussed for the monoatomic gases, for the diatomic gases, for the triatomic gases, or in general polyatomic nonlinear gases, what will be the gamma value? That is nothing but the ratio of Cp by Cv is called as a gamma. So, then what will be that gamma value? And then the relations we discuss Cp minus Cb equals to R, and I told I will discuss after the reversible and irreversible process, and then we are going to discuss the first law of thermodynamics, and then we will enter to discuss that one. Now, here first we need to know what is reversible process and what is irreversible process. Reversible process and what is irreversible process. In case of a reversible process, if I write down one picture, it will be give you more clarity to you. Suppose in case of a thermodynamics, always you have to understand system means cylinder, piston, gas molecule. That is nothing but a system. So, that is why in thermodynamics always you will think there is a piston is there, and in this piston there inside the gas molecule is there, the cylinder, the gas molecule will be there like this. This is a gas molecules, this is a gas molecules, and then you just imagine just one by one I am putting over here one by one, this is nothing but a sand particle. So, that means you look at when the substantial amount of sand particle will come, then only the piston will come down, and then this is a movable piston and it is a frictionless piston. That means if you look at this piston can move up and down, and this piston is there. When the piston is there, from the outside there one pressure is there, that is called as a external pressure, and then because of the gas molecule, the inside one pressure will be there, that is called as a gas pressure. Because you know in a states of matter, whenever the gas molecules will be there, the gas molecule is constantly collide with each other and also walls of the container. Because of this collision, they are exerted the force, and force per unit area is nothing but a pressure. So, that is why the gas molecule also exerting the pressure over here. Now, when the external pressure, when P external is equals to the P gas, then piston will not move, piston not move, piston not move. But if the P external is greater than the P gas, then the piston will move downward. We call it as a compression. We call it as a what? Compression. We call it as a compression. Clear? When the P external will be lesser than the P gas, then we call it as a what? Expansion. Expansion. That means you understand clearly, whenever the external pressure is more, so then this will give the pressure and the P gas not able to resist. So, then immediately the piston will comes down and then the volume will decrease. So, that is why we call it as a compression. Whereas, in case of expansion, what scenario is happening, you look at, when the gas P gas is greater, it will give the pressure this direction and the external pressure is less, the piston will go up, then the volume will increase. That is why we call it as a expansion. And now, here I put you in one situation when I am putting one by one sand particle. In that particular case, what is happening? That in that particular case, when the substantial amount of sand will come, then only the piston will comes down, and then piston will comes down very slowly, like that, slowly, and finally maybe coming over here, then slowly it will become very slowly, small change will be there, because one sand particle you are adding. And then this process is called as a reversible process. That means whenever we can now write down the what in case of a reversible process, what are the characteristics of a reversible process. Then you look at what I am telling, the total change is happening from here to here. During this total change, there are very small changes there, that is called as a infinitesimally change. So that is why for the reversible process, what you need to know in reversible process, you need to understand the first one is nothing but a, this is the infinite number of steps, infinite number of steps will be involved, infinite number of steps should be involved in a reversible process. And then the second one we can say infinite number of time, the reversible process almost never going to complete, infinite number of steps will be there, infinite number of steps, infinite number of steps will be, infinite number of steps will be there for the reversible process. First of all, I told infinite number of steps and infinite number of time. Sorry, this is not steps, this is a infinite number of time. So for the reversible process, you need infinite number of steps as well as infinite number of time. And then the third point we can say this, when I give the example, then you understand slowly I am putting one by one sand particle. Then what is happening? This piston is slowly coming, and then the system is getting time to maintain the thermodynamic equilibrium with the surroundings. I mentioned during the starting of this thermodynamics, I mentioned what is thermodynamic equilibrium. When at a time thermal equilibrium, mechanical equilibrium and the material equilibrium will be attained system and surroundings, that is called as a thermodynamic equilibrium, and the process is happening so slowly, so infinitesimally change is happening. So that is why the system is getting time to adjust with the surroundings. So that is why at each step of the process, 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 system and surroundings, system and surroundings, system and surroundings, system and surroundings, maintaining thermodynamic equilibrium, thermodynamic equilibrium, thermodynamic equilibrium. I told EQ to the power m means equilibrium. So that means at each step of the process, the total change is happening here to here. So at each step of the process, system and surrounding is maintaining the thermodynamic equilibrium. And then the fourth point we can say, whenever this type of infinitesimally small change will be there, that process also is called as a quasi-static process. The other name of a reversible process is a quasi-static process. So this is a quasi-static process. This is a quasi-static process. Quasi-static process. Quasi-static process. Quasi-static process. This is a quasi-static process because small infinitesimally change is there towards a big change. That is called as a quasi-static process. The fifth one, the P external, and if you look at whenever there is a compression will be there, P external is greater than the P gas. So then we can write down P external minus P gas will be equals to dP. This dP value will be very small because very infinitesimally small change is happening. So then we can write down this will be nothing but a very small value will be there at each step of the process. So then these are the characteristics. Moreover, the sixth point is very important point. When I will show you the first law I will explain, after that the work done I will explain over here, after that I will show you work done graphically. That time you will get this idea more clearly. The sixth point I am writing, the reversible expansion work, reversible expansion work is greater than irreversible expansion work. Irreversible, 1 year NEET they put question on this, irreversible expansion work, irreversible expansion work. The reversible expansion work is greater than irreversible expansion work. During the, after first law of thermodynamics, when I will graphically I will show the work done, that time I will show you the reversible expansion work is greater than irreversible expansion work. And these are the things you have to remember regarding the reversible process. Simple example if I give you, my dear student, you can understand very easily. Suppose this will not happen with you. Suppose you assume suddenly somebody told you your father is dead. How you will feel? Immediately you will get shocked after getting that information. But now same thing, but we are representing in a different way. Suppose somebody told your father met in some accident, I got the informations, and he took it to the Apollo Hospital ICU. He is there in Apollo Hospital Vanagaram in ICU. Something they told. Then you thought like that, okay, still he survived, he is there in ICU. Let me check what is happening over there. Then when you go over there, the doctor is telling, so there we need to make one operation, and he got very heavy injury in the brain, and then he told we doing the operations. After that maybe evening they are telling he is in coma, we did operations, we need for 24 hours or 40 hours to tell you he will survive or not. After 24 hours then they told he expired, sorry. But the same change is happening, you look at. Your father is died, but suddenly somebody is telling it is a irreversible process. But the same change is when happening, slowly, step by step manner, then you got the time to adjust yourself to get that shock, to get the news of your father dead. You mentally prepared. Slowly you prepared yourself. My father can be die because of this much of accident, ICU and operation. Then you got time to prepare yourself for that things. So that means that time you will not get that much of shock. Somebody when he is telling suddenly. So that is why that is a reversible process. That means the system will get the time to adjust according to the change. But whereas in irreversible process, the system will not get the time to adjust according to the change, sudden process. So that is why same thing, if I draw a picture, now I am writing irreversible process, and then I am drawing the picture, and then I will write down the characteristics. Then you look at the characteristics, irreversible process. So if you look at the irreversible process, so then in irreversible process, what is happening? I am drawing the picture. Here the cylinder is there, piston is there, and then suddenly here the m amount of mass is there. Suppose you look at here the gas molecule is there, suddenly this mass I am putting over here, this m amount of mass. Then suddenly the piston will come from here, suddenly. This will happen what? Suddenly the piston will come here to here, piston will come. Because suddenly I am putting the m mass over there, suddenly the piston will come down. So that means this process is called as a irreversible process. Then what are the point we can write down for the irreversible process? Irreversible process, we can write down like this way, is nothing but a, that the first point we write down, this is a sudden process, this is a sudden process. So that means irreversible process means what? It is a sudden process, okay. And then the next point I can write down, this is a finite number of steps and finite number of times should be there, not like reversible process, infinite number of steps and infinite number of time. finite step and finite time, finite step and finite time, finite time should be there. And then here the third point I write down, at each step of the process, the system and surrounding is maintaining thermodynamic equilibrium. But as this is a sudden process, the system will not get time. Likewise, if suddenly somebody told your father died, like that scenario, you will not get time to adjust yourself. Like the system also will not get time to adjust. So that is why only at initial and final state of the system, only at initial and final state of the system, only at initial and final state of the system is maintaining thermodynamic equilibrium, is maintained thermodynamic or is maintaining thermodynamic equilibrium. Thermodynamic equilibrium is maintain thermodynamic equilibrium. If I write down the fourth process, this is not a quasi-static process. You can write down that point also if you write. But moreover, main important thing I can write down that P external minus P gas, this is also compression. But in this case, this is what happening. This is I write down in this case that P external minus P gas is nothing but a dP was small. But in case the sixth point I write down, reversible expansion work is greater than irreversible expansion work. I told I will explain during after first law, I will explain after that when I will go for the explaining by the graph the work done, that time I will explain this one. And in this compression work, if I write down P external minus P gas, and this is happening sudden, so that is why this dP will be nothing but a what? Large. This dP will be nothing but a large. That means the difference between the two pressure, external pressure and the gas pressure, sudden happening. So that difference will be, but here in case of a reversible process, slowly happening. So that means that difference will be small at each step, but here the sudden, so that is why the difference will be large, will be there, the difference. And then immediately the fifth step, what I am writing over here, or I can write down there itself, it will be clearly visible. So then for the irreversible process, the fifth point, for the irreversible process, we can write down the fifth point over here. For the irreversible process, here itself I can modify and I can write down over here itself. For the irreversible process, we look at irreversible process. In case of a irreversible process, what we can write down for the irreversible process? For the irreversible process is nothing but we can write down here, you look at, we can write down, this is the fifth point, we can write down like this, the irreversible compression work, irreversible compression work will be greater than reversible compression work. This is the thing you have to understand. This is also I will explain after explaining the first law of thermodynamics, I will explain these things. And now just I will give you how to find out the work done. So if you just imagine this is a cylinder and the gas molecule is there and this is a piston, and the piston is a frictionless, it can move up and it can move down. This piston can move up, this piston can move down, depending on the P external is greater than or P gas is greater than the P external. And you know always P external is acting over here, this is the external pressure, and this is a P gas inside is there in the cylinder which is acting opposite to this one. And then when the piston is not moving, in that condition we can write down P external will be equals to P gas. But now we can write down P gas will be equals to minus of P external. because both the amount is same as their direction is different, then we can write down P gas will be equals to minus of P external. Then already we know the piston is moving here to here. Suppose the piston is moving here to here. This distance I am telling delta L. Clear? This distance is delta L. And already you know in a physics, work done will be equals to how much, my dear? Work done is represented by W will be equals to force into displacement. The same logic I am putting over here, force into displacement, force into displacement, force into displacement. Now the force is nothing but a, already we know what, my dear? Force is nothing but a, we can express the force by area, unit area is nothing but a what? Pressure. Force by unit area is nothing but a pressure. So this pressure is denoted by P. Force per unit area is nothing but a pressure. So then the pressure into area is nothing but a what? Force by cross multiplications. So instead of force, I can write down pressure into area. This area is nothing but a area of the piston, where A is the area of piston, area of piston. And then displacement, how much is there of the piston? Delta L. So that is why the force is nothing but a pressure into area, displacement is nothing but a delta N. Area into delta N, change in length is nothing but a change in volume. So this is nothing but we can write down pressure into delta V. So that is why in case of a gases, work done will be equals to pressure into delta V is nothing but a volume change, final minus initial, V2 minus V1. And now you look at, once you got the work done will be equals to PdV. But in chemistry and physics, here there is a difference. In generally, we will put over here work done will be equals to nothing but we can write down over here nothing but what? P gas into volume change. But P gas is nothing but a minus P external. So then you look at here itself we can write down minus of P external into dV. So that is why in case of a chemistry, always we used to take the external pressure. That is why work done will be equals to my W is nothing but a minus of P into delta V, because you know the gas pressure and the external pressure, they are acting opposite to each other. So as because of opposite to each other, then the P gas is nothing but a minus of P external. So then the work done W will be equals to minus P external into delta V. So simply we can write down W equals to minus PdV. The final expressions we can write down W will be equals to minus P into del V. This is nothing but a work done. And the next class we will discuss you from here itself, in case of a compression work, what will be the sign of a work done? In case of a expansion work, what will be the sign of a work done? During the irreversible process, what will be the work done? And in case of a reversible process, what will be the work done? We will explain in a next class, and then after that I will introduce the first law of thermodynamics. Then via graphical method I will show you the reversible expansion was is greater than the irreversible expansion one, and then irreversible compression work is greater than irreversible expansion work, reversible compression work. So I also told you these things. The next class I am going to discuss that thing. I hope you enjoy, my dear student. Thank you all. Thank you.